Alright, so alright. Okay. Alright. Alfredo. If you want to stay back there, you must be very silent so that I don't even realize you're not in your correct seat. Alright. Okay. Alright. So, it asks us here to find the x-coordinate of each relative minimum of f on the interval from -2 to 3, and we must justify our answers. So we should not even look at these last two lines right here because we're only talking about f. And if we are looking for maximums or minimums, we have to have the first derivative equal to 0, and we have to have a sign change on that derivative, right? We have to go to positive to negative or negative to positive. Actually, this one only asks for minimum, so we need negative to positive. So we are looking for places where our first derivative is 0, which happens at these two places. And so for those two places, where do we switch from negative to positive? Right here at x equals 1. So we would say f has a relative minimum at x equals 1 because f prime of x switches from negative to positive at x equals 1, or at that point, or something there. And since right here at -1, we don't change signs, we're negative and then negative again, we don't have any other minimums there, or maximums if they had asked for that. Okay. For B, it's asking us to tell why there has to be a value C on -1 to 1 such that the second derivative equals 0. Now, to me, it is difficult to tell whether or not it's intermediate value theorem or mean value theorem. Because if this said f prime of C equals 0, it would be intermediate value theorem because we have the values for f prime, right? So it would be intermediate value theorem if it was f prime. But we're talking about f double prime. We do not have the values for f double prime. So we don't know that it goes from like -2 up to 7 and has to cross a 0 or something. So this is a mean value theorem problem. And because it's f double prime. And so since it's mean value theorem though, we're not talking about f here for mean value theorem. We're talking about f prime. So we need to prove that f prime is both continuous and differentiable. All right, and so you do have to write this time for sure because they tell you that f is twice differentiable, but they don't tell you anything about f prime. Right? But if you can take the derivative of f 2 times, then f prime has to be differentiable. And if it's differentiable, it has to be continuous, right? So you have to say because, or since, f is twice differentiable, f prime of x is continuous and differentiable. This is just single prime right here. So it would not be enough here just to say f prime is continuous and differentiable. So you got to say it's because f is twice differentiable. I'd probably take it if it had told you f prime was twice differentiable. I'd probably accept that you inferred that, but since it only talks about f, you have to say since f is twice differentiable, f prime has to be continuous and differentiable there. So if this is true, mean value theorem must apply. Yes, we're going to have to write the points. So the points are -1, 0, and 1, 0, right? So so we could do the work over the side, -1, 0, and 1, 0. That's optional. The reason I did not is because up here, it does not restrict f to a certain domain. It just tells us f and g are continuous and differentiable for all real numbers, right? So I just went with the general, they are continuous and differentiable everywhere. So it would also apply that they're continuous and differentiable on this interval. The main reason I did that, Daniel, is because I honestly couldn't remember. I think they have to be continuous on the closed interval and differentiable on the open interval. And I couldn't remember which one whether I needed brackets or parentheses there when I said that. So when I looked back up here, I just said, well, it's everywhere, so it really doesn't matter. I think it's continuous that has to have brackets and differentiable that has to have parentheses. So since you don't have to do that here, I did not. But if you did put from -1 to 1, it would be okay. I think you should have bracket, have or equal to signs if you do that. And so I know that a lot of you are looking at this in your head and saying that the slope is 0, which is true. But I think you need to show the work for that. At least show where you do 0 minus 0 over 1 plus 1 and say that that is 0. I could be wrong, but I'd rather be safe than sorry. Show a little bit of work for that, even if it's a really easy one to do in your head. Right, so since, then we would say, therefore, by the mean value theorem, and then at this point, I basically just start quoting what the question said. Explain why there must be, someone say, there must be a value C for -1 less than C less than 1 such that f double prime of C equals 0. Will they count off if you don't say anything about continuity? Here it is okay because the C is an X value in that problem. In general, with variables, if you're consistent in what you mess up, if there's a f of t and you call it an x all the way through, and there's not an x variable anywhere else in the problem, then you'll be okay. They just assume that's what you meant. If there's an x somewhere else in the problem, so like if they call one of the functions x of t or something, or if you see an x variable anywhere else, then if you mix it up, they will count off. But right here, it is correct to say f prime of x here, yet they use a c here, so it's better to use that c value. I think if you put an x, you would probably still be okay for that. But you would need x's for everything, a value x for -1 less than or equal to x, or less than x less than 1, such that f double prime of x equals 0. Okay. Questions? All right. C. The function h is defined by this equation. We're supposed to find h prime of 3. Got to use a chain rule here. So h prime of x is going to be, how do we take the derivative of natural log?
It's 1 over x.
And in this case, it's going to be 1 over the inside stuff, which is f of x. Then you got to multiply by the derivative of the inside stuff, which would be f prime of x. So if you want here, you could go ahead and put that together. You're going to get f prime of x over f of x. So h prime of 3. And please, whenever you do this, write down h prime of 3. It shows the greater. Here's my general derivative. I found it with x's. Now I'm plugging in 3. Okay, so write down h prime of 3. And then f prime of 3 over f of 3. So f prime of 3 from the table is 1/2. F of 3 is 7. So we got 1/2 divided by 7. Dividing fractions is easy as pie. Flip the second and multiply, you'll get 1 over 14. Okay, questions? And for D, it's pretty much the same as C, except for what rule do we need to use for D? Product. So K prime of X revoke your blessings. Again, notice here, I'm putting K prime of 3. I think you could probably get away with like going ahead and plugging in the numbers there, but still label it as K prime of 3. Don't like just start plugging in numbers and act like it's a string of equal signs there. So you're just pulling this stuff from the table. F of 3 is 7. F prime is -2. I mean, G prime is -2. And then G of 3 is 1. F prime is 1/2. Technically, you can stop here. It's okay. But I would do this, -13.5. Since this is your free response that you have seen before, if you are trying to memorize it, it'll be easier to memorize -13.5 than it will be 7 times -2 plus 1 times 1/2. If you're wanting to memorize the answers to make sure you're getting the right thing in the end. Yeah. And your words don't have to be verbatim what I have here, but they need that general idea. Okay, questions? Negative 13.5. Okay. All right. Okay. Let's look at those last two examples that we had yesterday. Yes. What is costing y'all $200? Oh, beta convention. Is overnight. Oh, yeah. Yeah. Where's it at? What is it for? When is this? Yes, if you need me to sign your beta paper, bring it up here real quick. Remind me when this is coming up.
Teacher need to get signed. Oh, next semester?
Well, it's still me. Is it fourth period? It's still fourth period, isn't it?
I still need her to get it signed. Her and then
So,
Swat.
anybody else want their signed? Okay. Anybody else? I'm putting the pen away. Okay.
I know a great football practicing group.
Yeah, you can come practice with us. They probably all have sports right after school and we can't. But.
I think they got swim.
Okay. So. All right. All right, so for some reason, for some situation that we are not entirely sure about, we've got this wire, we need a square and a circle. All right, so what two formulas am I going to talk about here? All right. So area, I would have x times x, which would be x squared, plus pi r squared. That's what I'm trying to maximize. I want the biggest area that I can get. But that has two variables, and I can't solve that with two variables. So what other information can I use, Addison? Perimeter. The perimeter of the square is 4x, 2 pi r. This is supposed to equal 4. 4 feet of wire. Yeah, there's a little bit. I was also searching for a number and thinking you can't do it. Yeah. All right, so we need to solve this for either x or y. I would probably go for x here. So you solve for r, you got to divide by 2 pi. And I don't like dividing by 2 pi. So 4 minus 2 pi r, divide everything by 4. No, I don't think so, because you got a r and r squared, so it would not have been. So 2, I'm going to call this 2 minus 1/2 pi times r. It's not. Let's try that again. How about 1 minus 1/2 pi r? So we could plug this in for x. Area is going to equal 1 minus 1/2 pi r squared plus pi r squared. And if I want to take the derivative of this, I would need to, it's going to be easier to do if I double square. So 1 minus, that's going to be negative 1/2 pi r. When I double it, I'll just get negative pi times r plus 1/4 pi squared r squared there plus pi r squared. Yeah, looks like a variable, and then it makes you think. All right, so this derivative, I would give you something like this where you might have to take this derivative by hand. After that, we may use the calculator, I'm not sure. But this one is not that bad to take the derivative by hand because pi is not a variable, it's a number. So the derivative of 1 is 0. The derivative of negative pi r is just negative pi. Yes, thank you. And here, I'm just taking this 2 and multiplying out front. So 2 times 1/4 gives me 1/2. Leave the pi squared alone. R to the first power. And same thing over here. You'll get 2 pi r. So we want to see when the radius is, or when the derivative is equal to 0. I may give up and use the calculator in a minute, but I think I can do it. Let's see. Might give up. So we would move the negative pi over here, so we'd have 1/2 pi squared r plus 2 pi r equals pi. And then, if I'm trying to solve this for r, I'm going to factor out of r. And now I would divide both sides by 1/2 pi squared plus 2 pi. I'm going to factor pi out of the bottom also. And then those pi's can cancel. So I get 1 over 1/2 pi plus 2. And so here's where I'm going to give up and use the calculator because I don't want to plug numbers bigger. Alright, so let's just get a value for that. 1 divided by 0.5 pi plus 2 is 0.28005. I just knew that off the top of my head. Kind of like jacking that derivative back there. And so if I plug in a number to the derivative that's less than 0.28005, such as 0, even though I realize we can't actually have 0 as a radius, but I'm still going to plug it in. Because everything here, since this is the only critical point, everything here should be negative. So we're going to get negative here. And then if I plug in a number bigger than 0.2005, let's test it. I should get negative pi plus 0.5 pi squared times, I'm going to say 1 plus 2 pi times 1. I'm plugging it into this derivative right here. And I get 8 point, it doesn't really matter that much, it's a positive.
Where do you plug it in?
The R.
Oh, okay.
It's kind of hard to remember that the pi is not a variable here, right? So you're plugging it in for the R. And so what do we have right here at 0.28005?
Critical.
It's critical? What type of critical point?
There's negative deposits of
Thomas is telling me it is a minimum. Is he correct?
concave up.
Yes.
Concave up.
No, we don't know concavity.
Oh, we don't?
This is the first derivative. So we do not know. So this tells me that A would be decreasing here and then increasing here. So, what did the question ask us for? Maximum total area. Did it ask us for minimum area?
No.
No.
Oh, so we can't solve it.
We can? Nope.
Plug that back in.
Okay, so our variable we were using here was R, correct? So, between our radius could be 0. Between 0 and 0.28005, our area is decreasing. But then as our radius increases, then our area is going to increase infinitely, right? Forever. But we have a situation here where as the radius gets bigger, the area is increasing. But our radius is going to be limited because how many feet of wire do we have? 4. All right. So, it's telling us the bigger the radius is, the bigger my area is once I pass 0.28005. So, it's either going to be, so like our function's doing this right here. It's decreasing and then it's increasing. Right? So, it's either going to look like this, and our relative our absolute maximum's over here, or it could look like this, and our absolute maximum could be over here. So it's either best to use all of the wire for a square or all of the wire for a circle. We can test pretty quickly which one would give us the biggest area, right? So if we have a square and we use all of our wire for the square and we've got 4, we would have each side could be 1, and that would give me an area of 1, right? For the circle, it's a little bit more difficult. The circumference can be 4, right? So 4 would equal 2 pi r. So if I divide by 2 pi, you'll end up with 2 over pi would be your radius. And I'm just going to use the calculator here to do, actually no, I don't need to, because the area would be pi times that radius. Well, maybe I might need to. It's going to be pi times 4 over pi squared. One of those pi's will cancel. So you'll get 4 divided by pi. Actually, let's say this is calculator inactive. I realize I cheated there for a little bit. But is 4 divided by pi bigger than 1? Yes, because pi is 3.14, right? So you're best to use all of your wire for the circle.
So there's not even going to be a square.
There will be no square at all. I know, this is awesome. It's like number 33 back here where your answer is actually just a sphere. It's a little bit aggravating that they asked this problem in the first place, right? The question actually ends up being which one maximizes area better, square or circle, and the answer will be circle. So. Alright. Okay, now this one's going to take us a little while, but these are my favorite optimization problems, and we will use the calculator. Alright, so a boat on the ocean is 4 miles from the nearest point on a straight shoreline. The point is 6 miles from a restaurant on the shore. A woman plans to row the boat straight to a point on the shore and then walk along the shore to the restaurant. If she walks at 3 miles per hour and rows at 2 miles per hour, at which point on the shore should she land to minimize the total travel time? Okay, so let's draw a picture. Here will be our shore. Out here is a boat. Oh, there's no sail. This is a rowboat. This is we're looking at our, well, let's see. This is an aerial view here. So let's draw our little boat differently. Here's our little paddles. There we go. Is that better? Okay. All right, so the nearest point on the shore, which would be perpendicular, is 4 miles from this crazy woman that is 4 miles from shore in a rowboat on the ocean. Yeah, let's draw some waves. She's in danger. Those are waves. They're waves. Alright, so, now she realizes while she's out here 4 miles from shore in her rowboat on the ocean that she is hungry. And 6 miles down the beach here, so this is 6 miles down the beach, is a restaurant. Okay, so here's the problem. Though she could just go straight to the restaurant. Like in the boat, she could go take the boat straight to, the dock at the restaurant. But she only rows at 2 miles per hour. However, she can walk faster. So, she's got a ways to go. I just made up this problem. Do not get caught up in the speed of her rowing. It is their waves. This is not flat water. This is not a rowing team in the Olympics. So, maybe she doesn't know how to swim. There's sharks in the water. Look, I see a shark fin. She can't swim. Alright, so, she can't swim. So, she could go straight to shore and then walk the whole way. But the question is there an optimal point here where she could do both and optimize her time here?
Yeah, we did this exact problem, except there was a person standing and they threw like a ball into the water, and the dog ran out, and it was like, how fast can you get back to the person?
Right. Yeah. She decides to take a break from rowing, grab her pencil and paper and graphing calculator that she keeps on the boat with her for this particular situation, just in case. I've always got Desmos on my phone, and so, oh yeah, I've got the app, so it doesn't take derivatives, but it will do the graphic derivatives, so I could figure it out. So if we want to, just like quickly, we could do Pythagorean Theorem. So if we do square root of 16 plus 36, hypotenuse is 7.2111. So if she just rode straight there, she would have 7.2111 miles to go at 2 miles per hour. So if you divide by 2, so it would take her 3.6 hours. Yeah. She has good eyesight. She also has a telescope. Yeah. All right, so straight there would take this long. If she went straight to shore, how long would it take her to get straight to shore? 2 hours. And then how long to get to the restaurant? 2 more hours. It'd take her 4 hours if she did that. So she'd be better off going straight to the restaurant than she would be going straight to shore. But there are sharks in the water. Depends on. All right, so
Is there beach parking midway? Is there beach parking midway?
Let's assume it'll be safe to leave her boat along the shore anywhere. There's a... So. Alright. So. Alright. The waves are up. And it's just her out there. Yeah. Alright. So, we're not sure how far, but somewhere this amount from shore, let's say that she goes this far. Okay? So if this is x, what could we call this part right here?
X plus
6 minus x.
6 minus x. Okay. So her path that she is going to take is she's going to go here and then here. So we need this length right here. How are we going to find that? Pythagorean Theorem. 4 squared plus x squared is going to equal c squared. If we square root both sides, we'll get square root of 16 plus x squared. So that is this side right here. So we need an equation for her total travel time. So her total travel time, I'm going to call it capital T, is going to be, we're going to take the distance that she has to travel in the boat, which we just found is square root of 16 plus x squared. And we're going to divide that by 2 because that's how fast she goes in the boat. Plus 6 minus x, but we're going to divide that by 3 because that's how fast she goes whenever she's walking along the beach. So, like, whenever we were just figuring, we found out the distance, right? So if you know the distance and she's going 2 miles every hour, you can just divide there to get your distance. Like, whenever we found this is 4, we knew it was 2. So this expression here, square root of 16 plus x squared, is the distance that she travels in the boat. So we could do all of those things instead. Remember, she has her graphing calculator in the boat.
and plenty of paper.
She has her graphing calculator in the boat, so let's do that. Now, at this point, yes, technically, she has a TA 89, yes.
Out of luck.
84 will actually do derivatives at a point. Some classes only use the 84. They don't have 89s. Yeah, they're... Okay. So, I'm just going to type this in here. Now, just because of the fact that I'm making you do it this, I'm going to make you do it this way. You could graph that and find a minimum. But I want us to do the derivative because sometimes we get problems like this that we can't do without the derivative, and that's like the process that we're working with. Yes? I feel like that is false and that you are doing something wrong. But I will, whenever we get to that point, I will check and see what possibly you are doing wrong. All right, so if we take the derivative of y1 of x, comma x, it will give us that we got x over 2 square root of x squared plus 16 minus 1/3. And we are going to set that equal to 0 and solve. And since we have our trusty calculator, we're also going to do that in the calculator. I'm going to go up here and copy this. And we're going to solve. Paste equals 0, comma x. And so we get x equals 8 square root of 5 over 5. And let's actually get the... So it will be 3.577 hours. And yes. The surprise one, yes, it has. It won't be this, no. All right, so it will not be an optimization problem. No, we haven't been doing that long enough for me to give you that on the. All right. So now I should check to make sure this is in fact a minimum. Let's do that with the graph. I mean, it won't be on FRQ tomorrow, but if I give you something that's difficult, I will make it calculator active. And you can see here we go from negative to positive, so we should have a minimum there at that point. So this is our minimum time. How long was it if she just rode? It was... Yeah, so 3.6055, if we take that and subtract 3.577, she has saved herself 0.028 of an hour. So she has saved herself 1.71 minutes by doing this.
Wow. That's called efficiency, Dan.
Why is x equal to 3.577 hours?
That's 8 root 5 over 5.
So what's the answer? No, but how is x equal to that?
Oh, wait. That's distance. Sorry. No, that's distance. To find time. Oh, okay. Hold on. To find time, what do we need to do? Plug this back into the original equation. So, just so we got to know how much time she saved. So let me go up here and... Well, I should copy and paste that, but I can't. So. Okay, no, it's 3.49. So if we subtract that from, that's the distance. So, like, that's how far along the shore she should. Yeah, that's miles. So let me change that. I plugged it into the original to see what time it would take her. And so it was, what was it again that? It was 3.605. So if we take this number, yeah, the question asks what the point on the shore should be. So it should be miles, but this would be the answer. I'm just trying to figure out how much time she saved, which it doesn't ask. Yeah, the final answer is circled there. So I correct myself. She saves herself 6.8 minutes.
Yeah.
Totally worth it. So, I realize this is like a contrived situation, but we're going to look at one tomorrow that, to me, now I personally do not like putting pipelines or power lines or something like that. We'll look at one tomorrow that's very similar to this. To me, makes a lot of sense why you would actually do this. In this case, yes. It is curve sketching sort of stuff, so finding maximums, minimums. Yeah. We are going to do corrections for the FRQs. We're going to do those Thursday next week. All right. So tonight's assignment. Um, 18, 21, 25, 39, and 41. Same page as last night. Yeah, 262. 18, 21, 25, 39, and 41. Okay, just like last night, try something on every problem. Tomorrow, I have to go to training on the freckle math. So I think I'll be in here to for a set. Actually, I think I'll be in here for 5 minutes, and I gotta go train on the freckle math. So you will take your I'll check your homework real quick, and then you will take your FRQ. I'm not sure who's going to be in here. Probably another teacher, probably not a sub. I'm not sure though. So you will take your FRQ, and then I have made a recording for what I would have given as notes. It's pretty short. I think it's less than 20 minutes, and then you'll have an assignment to work on from there, which it's the last section of this unit, and I think it should be one you should be able to do fairly well without having me here.
18, 21, 25, 39, and 41?
Correct. Here. All right. Yes. You have 3 out of 4 right now. So if you bring it to me tomorrow, then you can get half credit for what you did not have, and you'll get 3.5.
So is it worth giving it all?
I mean, it's 0.5.
I might as well.
Ethan says might as well. Logan says forget it. Yeah, I would not. No, it doesn't cost a homework point to get half credit. It doesn't cost. So to get half credit, for half credit, you get 3.5. If you use a late work pass, you could get a 4 out of 4, but I would not do that so I would not use a late work pass, but I would do the problem to turn it in. Right. If you turn it in without a late work pass, you will get a 3.5. You could turn it in with the late work pass and get 4, but I wouldn't do that because the late work pass will be worth more than